Hey, it's kind of weird when there's like no MC, so I'll MC myself. I'm Kelsey Hightower. A lot of you know me from the Kubernetes world, and I find myself at .NET Conf, and this is super, super strange because I actually don't know .NET at all, but that's actually pretty good because today I'm going to ask you to either consider or learn a few new things. So I actually dusted off the keyboard and gave .NET a little tour over the last couple of days. So I'll kind of share a little bit of my feedback of what it's like for someone like me to jump into the .NET world for the first time. Don't worry, this won't be a language war or a language comparison, but it will be some kind of, hey, this is where some people are coming from in your community. And I think today the topic is like this focus on microservices. And the title of my talk is interesting. People say, "Hey, how'd you come up with that title? Stay sharp." Well, when you get an email saying, "Hey, what would you like to talk about? We need a title." This is what you come up with. But the bigger meaning here, honestly, is most people get very comfortable in their ways, right? So if you know Python or Ruby or .NET or C Sharp, sometimes we actually just stay way too tightly to what we know, and we do that for 20 or 30 years. Now, there's no problem with that, especially if you're getting value out of it. But I think in order to stay sharp, to keep your skills kind of where they need to be, it helps to pay attention to what's actually going on in the world to see if there are more tools or is there a better way to go about doing something that you're doing. So I think a little bit of experimentation is always helpful. So that's kind of the focus of today. And the other thing I want to do is make sure I can, what I wish I had when I was starting to think about microservices seriously. There's a lot of advice out there. There's a lot of what we call, or people will ask for, what's the best practice? And to be honest, I don't know what the best practice is. I think there's only practice, and maybe we'll talk a little bit about that. So I think the first question most people go to is, what's a microservice? Now, depending on who you ask, you're going to get a different answer, right? And I think we should probably start with the easier question than that one, which is, what's the meaning of life, right? I believe that this question is probably easier to answer than this one. And they both dive into kind of religious debates at some point. But I think the best thing you can do, honestly, is kind of focus on wherever you're at and try to get the most value out of your current situation. I don't know if there's a definite answer here, but I think the best thing to do is to focus on the fundamentals. This is the part where I think people go off the deep end the fastest. I was watching a little bit of Brendan's talk earlier, and there was a question around, how best to get to like microservices as if it's a ultimate destination. The truth is, whether you go with monoliths or microservices, I think the fundamentals can hold true in either of those particular architecture styles. So I'm just going to walk through what I believe are some of the fundamentals that if you were to think about them hard or closely, they might provide some value in the journey. That's all the slides I have. This is going to be a fairly short talk, and ideally want to optimize for a lot of Q&A. So maybe challenge some of the ideas that I'm putting forth. A little bit of background first. Someone coming to .NET for the very first time, it's very interesting. So some people will also ask, what's the best programming language or framework to be building microservices in? And I gave it a lot of thought. And the only thing I arrived to, honestly, is that the best programming language is probably the one you know how to use. Given the situation, given the task at hand, the ability to produce results is probably the most important thing that you can do. So if I go over to my laptop, you got to understand where I'm coming from. These days, I typically write code in the Go programming language, right? And I know what you're thinking. It's like, this is .NET Conf. How dare he speak blasphemy that there's another language that exists? But luckily for me, I think this is a pretty open community. But really, I'm showing you where I'm coming from to help you understand the way I'm particularly approaching this. And I think this is going to help a lot of people think about the path towards microservices. So for me, when I think about writing code or a service, in my world, I actually don't use the IDE. Now, I hear the life draining from the professional programmers who have like the enterprise grade IDEs. I actually don't use any of the IDEs. I actually use a very simple command line editor, Vim. So when I start writing a service, I like to keep things super small. So for example, if I'm going to write, let's say a Hello World app, right? Most of these services tend to look the same, in my opinion. You get a request, you do something in the middle, and you return a response. That pattern is pretty consistent. How many things the service does, well, that's going to be up to you. But here's a common approach that I take. These days, I tend to avoid large frameworks. And I'm going to show you why in a moment. But I typically try to build an app with as less code as possible. So when I'm writing Golang, if you can see here, I'm just going to walk you through. It's okay if you don't know Golang, but it reads pretty much like pseudocode. I'm going to log a few messages to my terminal. And I'm also going to just set up an HTTP server and respond to requests with hello world. Like that's super simple, right? So here I just start with the log message. I'm starting my app. Now here's the thing. Most people are like, why is logging so important? Well, trust me. If you're going from the monolith to a microservice world and you don't have good logging between those services, it's going to be damn near impossible to debug. Don't skimp on the logging. Even better, structured logging becomes a big deal here. If you haven't seen structured logging, imagine adding context to the things that you're printing, like the service name, the service IP, what other service it was trying to talk to. You probably want to have a lot more context than you normally do when you're all running in the same monolith. And then down here, if you look at it, I'm just adding a header saying what my runtime is. It's Golang. And then here's hello world, and I just bind to a service. Most people that are good at any of their programming languages can probably figure out how to do this in a very simple way. The next thing that I do in part of my workflow, again, a little bit of my background, is I like to test things locally. Now, why am I talking about testing things locally? I've seen a lot of people get into microservices and believe that their whole world needs to change. Some people believe that you have to install Docker, Kubernetes, Cloud Foundry, 1,000 tools on your laptop just so you can write a microservice. Microservices are supposed to be a bit smaller. So when developers go around asking for like a terabyte of RAM on their laptop so they can actually replicate production, there's two things there. Number one, you'll probably never really replicate production. You can probably get close to the workflow, but I don't know if you can ever get close to production. The second thing is, I don't know if you should necessarily write any service that requires a specific infrastructure to run. So whether you're looking at Lambda or Kubernetes or Azure Functions, ideally, you don't write code in a way that only runs on one of those platforms. Ideally, you want to preserve a little bit of agility depending on where you want to run. Typically, I test locally. So I'll just run this app locally. And my workflow these days is just hit it with curl, right? As long as it works with curl, I know that I'm pretty good in terms of moving on to the next step, which is deploying this particular app. And then we're going to get to my attempt at learning .NET here in a second. And don't laugh at me. I'm a new person to this world. Okay, so we have hello world. Now, in my world, I like to try to normalize my programming language or framework of choice using container images. Now, I popped over to the schedule, and let me click on this agenda. There are a lot of Kubernetes talks at this conference, like a lot of them. So today, there is no need for Kelsey to talk about Kubernetes. So I appreciate all the other speakers that will be talking about Kubernetes today. And if you're interested in Kubernetes, I really think you should stick around for those. I'm just going to focus on maybe the price of admission to those container runtime platforms. So for me, no matter what language I pick, I try to normalize that decision as fast as possible. So in this case, this is a Docker file. Maybe you've seen one, maybe you haven't. But all of these programming languages have a different way that you go about either starting the project, building the project, or even packaging up its dependencies. One way that we want to normalize as much of this as possible. And who better to figure out how to build an app and how it should be packaged than the actual developer? I think this is super key when you start to think about your microservices. A lot of times it's best if those services are self-contained as much as possible. And that also means being able to produce an artifact that can be deployed anywhere regardless of the runtime. So if I step through here, I'm doing a bunch of Golang specific things. And then here I'm just running the Go command to create a static executable. I like to keep these things super lightweight. And then I can package this up and build it. So if I were to build this application, you'll see here that I'm just using, you could use Docker. I'm using a hosted build service inside of my environment. But ideally, you're going to submit up your source code and have a container image built. Once you have that, I like to think about deployment. So if everything works on my laptop, that is my litmus test, then I deploy to the simplest environment when I'm getting started. Now, I'm known in the community for being the Kubernetes guy. With Brendan Burns and Joe Beta, I wrote a book called Kubernetes Up and Running. But these days, I actually don't turn to Kubernetes first. Okay, so if you're Kubernetes fans, I apologize. But here's how my workflow looks these days. Once I package my app in a container, and I'm thinking about this kind of services model, I'm trying to deploy to the easiest, no friction platform that I can. So typically, I'll pick some serverless thing like Azure Functions or Azure Container Instances. If you're in the Amazon world, that could be Lambda. And in the Google Cloud world, I would probably use something like Cloud Run, mainly because it gets me close to using the artifact that I produce in the previous step. Now, the goal with this is once I build my container image, I can just deploy that image from my container repository, hopefully hosted somewhere else, maybe in the cloud if that's your thing. Now, I'm going to show you how this works in the .NET world, just so you can kind of see that I think most of the workflows are going to be roughly the same. So if you're on the fence about what's the best framework, what's the best programming language, ideally, I think you can put your mind at ease because I think there's higher level concerns that should be where your focus should lie. So now that my application is deployed, I'm just going to hit this URL really quickly, and maybe we take a peek at how it was deployed, but this is my workflow these days. I run my app, we can see the header is set to Golang, and we see hello world. Great. That's my workflow. So whether I'm working on 5 microservices or 10, a lot of times what I'll do is host the dependencies, the things I'm not working on, and code locally and stay local as long as I can. Only when I need to complete a deployment do I actually worry about containers or the serverless platform that I'm using. But day to day, I have not given up my local development workflow. So if you're using something like VS Code, ideally you do everything there. If it works there, you can pick and choose the platform you deploy to. So what about the C# world? Okay, this is how I started. So I looked at it and I was like, maybe I can do something like this, right? Program.cs and just start writing code. That didn't actually work well for me, right? So what do all good developers do when they don't know how to do something? They go to Twitter to complain. I am no different. So I went into this .NET thing thinking it was a programming language, but it seems I stumbled upon a mini operating system with support for multiple execution environments, programming languages, and now I have so many questions. And I still do, but I've been educated quite a bit. Luckily for me, people like Scott Hanselman exist in the world. And you can see people are calling Scott Hanselman to the task like he's Batman. And eventually Scott Hanselman will appear. I believe he was probably sleeping and he just knew something was not right in the world. And he jumped on Twitter and he explained something super important to me. This block here. .NET's the ecosystem, CLR is the JVM, C#, F#, VB, and others are the languages, and then a bunch of other stuff. And I looked at it and it says, well, this is just the way that things work in .NET. But I got a lot clearer about what I actually needed to do. Later on in the thread, he also shared something pretty cool about how you get started. So he mentioned that I can actually just run a get started command to actually pull this off. Now, here's the thing. All I want to do at this point is write a simple service so I can get back and integrate it into the workflow that I already know. I don't want this language to be a big distraction to me, so I'm looking for the shortest path possible to using this particular program. And you'll see that a lot also in the real world. It's not very common that you see one company using a single programming language for everything. So I have a lot of empathy for developers that have to context switch between things like Python, Node.js, C#, and maybe the Go programming language. But this is pretty common. So what advice did I get? Well, the first thing they said is you can just run this command, .NET new web, and give it a name. I was like, oh, sweet. So I run the command, and a lot of things are happening. Something about ASP.NET. I do remember that from back in the day. And I cd into this directory. Now, remember where I'm coming from. I'm coming from a world where everything lives in this one file. I'm only using this standard library. This is where my mind is. You also notice there's no classes, there's no object-oriented business here. And I come into this world and I'm like, all right, I'm ready to go now. And I run the ls command. There's a lot more files than I think is necessary here. There's also this other folder. I have no idea why this stuff is here. I have no idea why I need it, but I figure that's the way it works. Now, what's the next step that I need to do? So I can pretend like I know the programming language. So I started with program.cs. Now, here's the thing. When people ask you to dig into the world of microservices, Kubernetes, and containers, they're expecting you to learn a lot. And a lot of the things that you see, like Docker files or Kubernetes deployments, I bet seem just as daunting as a Go programmer looking at a .NET application for the first time. So right around now is when I was like, I don't know if I'm going to figure all of this out anytime soon. And plus, I'm not using a nice IDE like VS Code to help me. I'm still in Vim with no syntax highlighting and no plugins. That's just the way I write code. But luckily for me, I scroll down, some of this stuff starts to make sense. I'm not going to pretend I knew exactly where to go in the beginning, but one thing I did figure out is most of this stuff is pretty much the same. The fundamentals are pretty much the same. So one thing that I figured out was you can actually just go into this program.cs. I'll drop down to the bottom. The only changes I really wanted to make here was like listen on port 8080, maybe something fancy like pull the port from the environment variable, and then just listen on that particular URL when I start up. And then I learned, after many hours of just trying to do this myself without looking at any other docs, I learned that you can edit this startup CS file. And then down there in the CS file, again, there feels like a lot of boilerplate here, but I get it. The fundamentals are roughly the same, right? I just want to respond, hello world. I figured out that this context response has a headers thing, and you can add headers directly to the code. All right, we're getting somewhere. So now that I got that to work, the next thing I did was figure out how to run it. And again, shout out to Scott Hentelman for helping me figure out how to actually make this work. Turns out I can call the .NET run command. It will compile it, even though I'm on a Mac, not on Windows, and it still works. I think this whole .NET Core might be the greatest thing that happened to this whole .NET ecosystem in a long time, because I remember there was a time where you had to have a Windows machine in order to make this work. Now, the last thing I'm going to do here is just make sure that local development is preserved. We'll also hit curl again. And it looks like it just works. We'll do -I, and we can see the header is .NET. Now, here's the first thing that I do once I figure out I can actually write code in a new language. I figure out its build tools. At this point, it's probably going to be largely syntax and learning some few frameworks. I need to get back to normalizing my workflow as fast as possible. And this is the key. So for me, I'm going to turn back to Docker to take all the things that I've learned and take all of these steps that I would normally run on my local machine. I'm going to throw them in a Docker file. So basically what I'm doing here is I'm going to just start from a Microsoft approved .NET Core image, going to run it on ideally a Linux operating system. That's where I'm going to be deploying. And I'm just going to make sure that all my code gets uploaded into this work directory app. And then I'm just going to do all the .NET things to create my release. Once I get it right just once, I know that this will be a repeatable process. At this point, I'm now back into a workflow that I understand. Different programming language, maybe optimized for the use case. But the nice thing is, it turns out I can probably do anything I can do in the Go world on the .NET platform, ideally with C# or F# of my choice. And at that point, guess what? The same scripts also work. I can just run the very similar thing here. I can run this deployment object. I'm going to do that now. And what I'm doing behind the scenes is I'm leveraging not Kubernetes, even though I'm using containers. I'm pushing both of those container images to a container registry. All the cloud providers have them. You can also run an open source registry if that's your choice. There are going to be a few differences. For example, even though .NET is fairly slim these days, I'll be remiss not to warn you that you're probably going to end up with like maybe 42, maybe I heard maybe as low as 30 megs binaries or tarballs that you spit out from Docker because you have to bundle all the dependencies, the runtimes, and everything you need. But the good news is, once everything's bundled, you don't need to worry about installing any of that stuff on the other machine. So I think the trade-off is worth it. Again, this whole container thing is allowing us just to treat both of these things the same. Now, I know you're probably curious, like how big is the Golang one? So a static binary and Golang, they're actually fairly big, but both of these are compressed, and you can see here I'm about 2.2 megs. Now, why does size matter here, right? So most people are like, Kelsey, we're not shipping software on floppy disk anymore. What's the big deal between 42 megs and 2? Well, it turns out storing these things costs money. So the larger the images, the more you pay for storage. The other thing is when we're deploying these things, you have to stream those bytes from a registry into your platform of choice. Today I'm using Cloud Run, and what I've done here is I've deployed .NET to this particular instance. The reason why I like to start with this when I'm doing any microservice is just because I don't want to think about infrastructure. I want to delay that as much as possible, and I also don't want to code my app to any other platform, whether it's Docker or Kubernetes. I want to make sure that if it works on my laptop, it can work on a VM, Kubernetes, or a serverless platform. So if I click on this link, ideally what should happen is we should see hello world, and you can see that we're doing this from the .NET instance of my app. Now, a lot of you would be like, so how's that any different than what I'm currently doing? That's a great question. It shouldn't be very different from what you're currently doing. For example, 5 years ago, I wrote this blog post on Medium. Remember when we used to write blog posts on Medium? I heard that's not the thing anymore, but 5 years ago, it was. And I had this blog post called 12 Fractured Apps. It's a play on words because when I learned about microservices back in the day, 12-factor was all the rave. So this is a dawn of the platform as a service. What's a platform as a service? One popular one would be things like Heroku. Always got to give them a shout out. Back in the day, I would say Heroku was one of the best platform as a services and arguably still is. You just focused on building your service, kind of like we just walked through just now. And then once you build your service, you can run their command line tools and deploy your app. I don't know what the hell this is. This is not the platform that I wanted. So we'll scroll down a little bit here. You can find it on your own, but it's from the Salesforce folks now. But they came out with this 12-factor manifesto. And it gave some guidelines on how we should write our services to be portable, lightweight, and ideally, if you do those things, they'll be easier to maintain down the road. I encourage you to go study up on the 12-factor app, especially if you're thinking about going down this road of microservices. I really think you got to make sure you avoid the common trap, which is starting with these small services and then ending up with like hundreds of mini monoliths, right? Back where you started, but more of them. Wrote this post called 12 Fractured Apps. And the thing about it is most people jump into microservices without understanding the basics. So beyond 12-factor, what do I mean by 12 fractured apps? Well, fracture, if you get injured, maybe you don't quite break your leg, but you fracture your bone and it hurts like hell every time you try to use it. A lot of people apps are exactly like that. So if I were to scroll through this, there's a couple of things that I always ask developers to think about when we're dealing with a services world, meaning services tend to change often. They may move across different platforms, and we want to keep that agility. But the thing is, the infrastructure alone can't do everything. So a few things I want to focus on. A couple of things. One is when you're actually connecting to your application, one of the things in a 12-factor manifesto is going to be you should be able to leverage things like environment variables for everything. I kind of disagree with that one. Platforms like Kubernetes these days allow you to actually use configuration files. And one thing I encourage people to do, though, is to be able to start with environment variables, but fall back on a config file if that's what your app needs. You don't need to go and rewrite everything, but it's a valuable tool if you want to give people more configuration options. We'll scroll down a little bit more. Now, this is one that really, really makes system administration hard, especially for people trying to manage your app. Think about what it takes to connect to a database. Don't worry about the code that you see here, but basically, I need some configuration, maybe some credentials, and I can connect to the database. But what I see most people doing is they connect to the database. If it doesn't work, their app just crashes. If you're writing services this way, no matter how good the infrastructure you deploy to, it's going to be a nightmare to manage. Number one, you can't make any assumptions, especially in the microservice world, that any of your dependencies will be up at any given time. This is one of the biggest mistakes I see when people move into the services architecture for the first time. What ends up happening is people have to create these complex scripts to try to manage your application to start things in the right order, and it just makes rolling upgrades damn near impossible to do. What do I actually recommend? Well, I recommend what people do. I'm going to show you a little trick here that you can see inside of my logs here. I'm going to just scroll down really, really quickly. So in my logs, what I like to do is use a bit of code. I'm going to just show you some logs really quickly. Here, what you'll see, that same app trying to connect to a database that doesn't quite exist. What I like to do here is assume that I'll connect to the database, and if it doesn't work, I'll just log repeatedly until the database eventually shows up. This set of logic inside of your app will go a long way to not assuming that you're going to be on the same server as the database or the database will always be there. The same is true for your dependencies. I'm going to cover one last thing before we jump into the Q&A. I'm hoping I'm sparking a few questions for you all. The last thing is code is a liability, all right? So I created this framework called no code. And a lot of people got excited about this. This is a pretty popular project, actually. It has 42,000 stars. Let me show you this. This is enough stars to actually start a business and raise VC funding. I can probably get an A round with this many stars. No customers, but a lot of GitHub stars. The other thing here is, if you think about the no code, the philosophy here is that, listen, code is a liability. The more code you write, more likely the more bugs or security or complexity you're going to introduce. So the no-code framework was giving people kind of the extreme measure of only write code when you have to. I encourage you to poke around here, but the big takeaway here is try to find a lightweight framework, because a lot of these platforms, to run efficiently, you need to make sure that you're not going to explode the number of resources going from maybe a monolith to a bunch of little services. You don't want to double the memory and CPU footprint when you do that. So you're going to have to think about how you shrink down those services and only have the code that you actually need. With that, I'm going to end the presentation, and hopefully there's a bunch of questions for us.
All right, Kelsey, let me bring up, there we are. There's the two of us. Thank you so much for joining us, and a lot of good insights there for folks that are getting into and building microservices, want to build an entire system architecture. And we particularly, I lost your camera. You still there? There we go. In particular, we have a question from Sumant asking, do we need containers for microservices? And we saw how you made that quick jump from write a little bit of code, put it in a container so that you get that assurance when you do deploy. Do you feel like containers are kind of central to our experience as a developer?
So I'm going to say no, and I have to have a little caveat here. The reason why I say no is, if you noticed when I was writing my Go and fiddling around with the C#, I focused on making sure everything worked in my local environment, and I didn't need to rely on containers to do anything. I don't want any of the container stuff leaking into my code base or any assumptions I make when I'm writing code. For me, when I do code reviews or I'm watching how the people on the team are developing things, that will be the immediate code smell that I give. It's like, hey, will this work outside of a particular implementation or deployment pattern? Now, why would you use Kubernetes or containers having said that? Well, the nice thing about containers is when you ask people to deploy your app, right? So let's think about a world without containers. And I've lived that world for a very long time. In that world, people need to know what's on the server. Maybe you have to put the runtime on the server first, depending if you're using dynamic linking. There's a lot that goes into prepping the target for the thing you want to run. If you look at some of the newer platforms like Kubernetes or Azure Container Instances or Azure Functions, a lot of the container-based platforms, the price of admission for ease of deployment, consistency, regardless of language you're writing, is you need to probably package it up in a container. And the analogy I like to use, if you're shipping packages, let's say you have a phone, maybe some batteries, whatever it is, if you walk into a FedEx, for example, with a bunch of loose items, the first thing they're going to do is they're going to tell you to put it in a box,
Yeah.
mainly because the rest of their infrastructure, their cars or their trucks, their planes, and the carrier, they don't want to be dealing with loose items. They want them to be packaged in a consistent way. They don't really care what you put in there, but they need a consistent way to be able to promise you that it'll get to the other side on time. And that's the way I view containers. It's a hidden technology, ideally invisible to make your life a little bit easier when adopting these other platforms.
And I like the comparison to packages, right? It's a great packaging and distribution framework. We see NPM in the NuGet in the .NET world. We use NuGet. Put your application in a package so that you do get that standard deployment.
And I like the fact that you brought up those package managers. And if you don't mind, I want to pull
Please.
on that thread just a little bit. So those packages have gotten us a long way. Whether I'm on Red Hat, I can use RPM. You
Mm,
just mentioned a couple of other popular ones, and it seemed there was a period where every programming language had its own packaging format.
mm.
And when you're switching between them, you would have to learn a whole set of tools. I still think they're super valuable, but the nice thing about this whole container image, it's language agnostic. You
Yes.
still use all of those package managers. So you still use the thing that packages your libraries, versions of them, making them easy to distribute and manage your dependencies.
Hmm.
But when it's ready to package for that final deployment, that's where container images start to really, really shine as this universal application packaging format that doesn't try to supersede or duplicate what the individual language packaging tools are doing.
Yeah. Oh my gosh. Right. It's in the old Windows world, right? We have little install shield things so you can install and update all the things. Much easier to do with a container. And you also showed us a bit about how you really take logging to a next level when you get into containers so that you can start to track and get a little bit more information coming out of there. I feel like that's really important for us when we do get into thinking in containers, not just microservices, but when you're thinking with containers, logging becomes much more important. Can you talk a little bit towards what steps you want to take once you have logs being emitted from your containers so that you can actually do something with that? Where, right? We get logging output somewhere, don't we?
Yeah, so you hear this quite a bit with these modern platforms. So what make these modern platforms different from the ones we're currently using? Typically, to get this consistency, to get this scale, to get this level of security, that means we tend to lock down the host. And when
Yeah.
we lock down the host, we tend to take away the ability to just log into a machine and do all the things that you were doing before. And that presents some challenges. And this is why, whether you're talking about a monolith in a container, and it's doubly true when you start to think about splitting your app across multiple containers. You
Mm,
need way more visibility than you had before, and logging and metrics come to the rescue. So, this is why, even in that 12 fractured apps post, I talk about the simple thing of, hey, my app has started and I've been able to reach all of my dependencies. Here's what they are, here's what I'm using. Simple log statements like that are a godsend when it comes to trying to troubleshoot these things. So in the container world, a lot of those platforms, whether it's Kubernetes or it's Docker or it's Cloud Run, all of those particular platforms tend to assume that you can just spit your logs out on standard output or on the console for the people on the .NET or C# world. If you're just spitting things out to the console, then you have the ability to have the platform take those logs and centralize them for you.
very cool. Yeah. Get that dashboard so you get the insight from above. There's another question here I want to bring up from Twitter. Let me put this up. Does it make sense to actively and aggressively use containers and Dockers in development, or are you saving it to only package at the end?
So here's I remember I was going to GitHub and I found a little tool I wanted to try. I was like, oh sweet, here's this tool. I'm going to download the binary and run it on my laptop. And the tool said you can run this using Docker. I'm like, no, 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 no. I actually don't have Docker installed on my laptop anymore. I don't want you to force me into a platform up front, right? If I want to deploy it in Docker, I would really appreciate it if you had a Docker file so I can build it myself.
Mm,
Without that, I'll like a Docker image and maybe I trust you. But for
okay.
the most part, in the Go world, especially, we like to just download the project and then call Go builds using our runtime of choice. So that's where it is. So when it comes to development, one thing I do agree with is using the container or the platform that you'll be using in production as early as possible. So if I'm going to run integration tests, I may choose to run those
Ah,
integration tests using the packaging format that production will be using. That way I can
sure.
get all the integration there. So if you think about it in CI/CD as a developer, think about our workflow, right? We're
Hmm.
typically doing things like linting, maybe we run some tests locally. And you know
Yeah.
what? Maybe I call Docker build locally just to make sure that Docker file is still good.
Get that sanity check.
Get the
Still
sanity
works.
check. But then when I push to the repo, I want my integration test that hit dev to be like, all right, we're going to build, test, and package.
Yeah.
And whatever ID I assign to that package, container in this case, we'll deploy to the target so we can run all of those integration tests. Maybe we're intermingling with some dependencies that have been deployed. If
Sure.
everything looks good, I can take that blob, that package, that container, and let that static artifact, unchangeable, this immutable thing, go up the stack. We never rebuild it again.
Sure.
And that's when I like to do that process. But I've seen people go the other way where they say, hey, everything I'm doing, I want to have Docker on my laptop. So every time I hit save in my IDE, I want to rebuild the container, deploy it to Docker, and see if it works. I just
Mm.
don't know about that because I've been through too many transitions from like Vagrant and virtual machines to now Docker and this other thing that it's not about the deployment target that should be the validation if our code works. The runtime should be the thing, and then integration testing should surface as many issues as possible.
Yeah. Yeah. So really, you're also speaking a little bit towards we can deploy that container to someplace that we can run our integration tests. But if it passes all of them, we can get into things like continuous deployment
That's right. That's right.
and then deploy, let Kubernetes pick up, orchestrators do their thing at that point.
You brought up a good thing. Those things are what I call last mile technologies. A
Yeah.
VM can run a container, Kubernetes can run a container. But I like to decouple that from my day to day workflow so I can focus on just writing code and, um, intermingling with the dependencies locally if I can.
It it feels more like a DevOps type of responsibility when you do get to Kubernetes at that point in the stack. I've focused as a developer, like you're saying, and I'm happy with my process. Let the DevOps folks handle the coordination and the deployment at that point.
And sometimes you're both. I just think it's
Mm,
really great for the context switching method, right? Because a lot of times once you do get your Kubernetes templates all set up nice and neat, you get your Docker file nice and neat, you tend not to revisit those things unless there's major infrastructure changes. So you want that front loop to be super tight and super integrated to your current developer workflow. And sometimes that doesn't mean building a container every time.
yeah. Oh, absolutely. There's a question here about the risks of not using a container orchestrator. Let me bring this up. This is a question from Gopal. It says you mentioned at the start something simple like Azure container instances rather than Kubernetes. Can you elaborate a little on the risks of not using a container orchestrator like Swarm or Kubernetes?
So the question here is really like, why do I need Kubernetes? I need Kubernetes ideally to run my app on some compute. I need memory, I need CPU, and maybe I let Kubernetes be in charge of orchestrating how those things get consumed. So if someone said, hey, you have 100 virtual machines, how would you go about managing the resources on those machines? Well, in that
Mm,
case, it gets a little bit more obvious, like Docker Swarm, Nomad, or Kubernetes might be a better fit than me writing a lot of bash scripts. There are a lot of people with a lot of bash scripts. And you
yes.
can go that route. I'm not saying it doesn't work because I rolled that for a very long time, but there's some nice things that you get from these orchestrators. They do things like if one of the machine dies, they reschedule your workload, aka container, on a different node. There's just so much you get out of the box between these tools that if I'm dealing with virtual machines and I need to have something map my application to resources so it runs, I'm going to pick something like Kubernetes. But if I already have an orchestrator built in to Cloud Run or Azure Container Instances, now we're in a slightly better situation. There is no machine. Here's
Yeah.
my app. you run it. Ain't that a good place to be? So when someone can do that, right? Maybe not for every app in the world, but if I have an app that can run in an environment like that, why not? And in that
Sure.
case, you don't need an orchestrator.
The, you're speaking and you're hinting a bit towards serverless applications.
Yeah, I think so. The nice thing is serverless has multiple meanings. So for some
Yeah.
people, it's going to be a function that's event driven, and that's cool if that's your definition. When
Hmm.
I think about serverless, and I think some people have made this point many times in the past, serverless is like the name implies taking the pain away. Servers, for a lot of people, if you've been on call before, like I have, represents
Same.
right. It
Yeah.
represents a bunch of pain you don't want to relive. So whenever there's a server, there might be pain. So
Hmm.
if we take the pain away, serverless, we end up in a different world. So how would that world work? Number one, we won't be talking about or exposing any servers. In that case, if you have an app, and it doesn't matter if it's a container or not, but most of these no server, serverless platforms are
Oh yeah.
saying, give me your app in this format and I'll run it for you.
Yeah. Right. And I think back to, gosh, you're reminding me here, times on call. When I was on call, we had our servers were physical hardware, right? We had two servers, and the application ran during the day for schools. And you know what? The time to update them was in the middle of the night, and you could take them down, but we were deploying. We didn't have a package, right? Being able to package and deploy and having that choice that we're seeing now when we choose containers, when we choose some of these deployment technologies and orchestration makes our choice around how we integrate, how we deploy a lot better. And there's something to be said about the orchestrator then, right when it bleeds off the current flow onto one server and allocates another, where in
Yeah, I
the
think it's
cloud.
healthy for people to think about this like they think about the CLR, right? Like this thing knows how to run multiple programming languages because of the interfaces that it provides, right? The libraries it
Sure.
provides. So when I think about these orchestrators, they allow us to encapsulate the complexity between the languages and how they make syscalls. And they just give us much better contracts and interfaces between what we're doing, what we're writing, and how it's actually running. Most people write their code and let the runtime figure out how to allocate memory, garbage collect memory, get CPUs, and all of that. So if you just zoom out a little bit, these orchestrators are like that for infrastructure, right? You don't make direct system calls typically. You typically don't write assembly, and you typically
Sure.
don't allocate your own memory in some of these runtimes. Think of it like that.
Okay. It makes a lot more sense when you think about I'm distributing what were all the pieces of my monolithic application. In fact, we have a question here that just came in over Twitter from this is ATX Dev Dude. Let me put this up so everybody can see. Kelsey, is the way to think of microservices as individual applications that run logic that would have previously been built as one giant app?
You can think of it that way. Like again, I don't think there's a right way, but one, let me talk about some experiences I've had. I've managed teams who've written many languages. I've written many languages, and when you're approaching it from the first time, let's say you already have a monolith. So one thing I think a lot of people can reason about pretty easily is if I have one project, and let's say I need to be able to allow users to log in, and then once they're logged in, they can edit their user profile, and then once they're done with that, they can buy something. Well, if I have one project, I just start hacking away, exposing all three of those endpoints, and there you go. Everything's in one place. And for
Yeah.
most people, that's fairly easy to deal with, right? I call this method, and this method gives me a response, and maybe I call this other method. That's
Yeah.
pretty straightforward.
And
Uh,
you could have done it in one file, like you were showing us earlier with Go. It
exactly.
could all be in one place.
It's good. Now, when people start to think about a microservice, maybe start to say something like, let me explain one of the microservices that no one considers a microservice because it's so obvious. DNS,
Yes.
right? DNS is a service that runs over there, has a pretty clean interface. When you want to go look up some other host somewhere in the world in the network, your libraries transparently call DNS and get a response, and then you keep doing what you're doing. And it
Mm,
makes sense to split out DNS servers because someone else can host them for you. You have a choice in the matter. That's one of the most common services that everyone has. So even in the monolithic world, if you squint real hard, if you're really looking to update that resume or add something to that LinkedIn profile,
sure.
now you have permission to say you have experience with microservices because you're using DNS.
You're using DNS.
So let's carry that over to your own app. Let's say that login portion, you want to support different ways of logging in, maybe username, password, jot tokens. And now the team is hot and heavy on the authentication piece. And now
Mm,
you're starting to notice that you're touching the whole app just for this authentication work. And people are like, dude, why are we like deploying 25 times this week because of this authentication thing? So then
yeah.
you start to run into issues around conflicts. There's no deployment to get your change. There's a whole
Code
list of
merge.
reasons. Code
Yeah,
merge, and a lot of them are organizational. So one thing,
sure.
and I like this approach, and I've done it in the past. Let's say we take the login service and we move it to its own standalone thing.
Okay.
Now the interface goes from methods, and maybe they can still be methods if you're using something like gRPC. There's talks on that later today,
Mm-hmm.
but it could be HTTP, whatever you want. Now this thing runs over here in isolation, and then what that team can do is maybe the first order of business, and this is the way I used to do it. Take the monolith,
Mm-hmm.
make a new name called off service. Here's the
Yeah.
trick. It's still a monolith,
Yeah.
and all I do is expose just the off components. Then in this other monolith over here, I say, hey, I'm going to add a little bit of client code to say either use your local library or talk over the wire to this other thing. And the truth is, we don't tell anyone. It's also the same exact monolith, but we want
You've
to iterate it.
duplicated it.
You've duplicated it. And
Yeah.
then some people will start that way where you then strip away all the things you don't need, and only thing that's left is the off service. And now you can iterate a little bit faster and keep the contract the same. That's one of the benefits of doing this. So what I would say here is if you can find a way where you can split around either organizational lines or something that just makes a lot of sense like DNS, that's where it starts to get interesting to carve out. I'm going to say one more thing here.
Sure.
Typically people land in microservices world when there's something new that comes up. For example,
Oh.
you want to integrate with Alexa or the Google Assistant. Now you could go look at that monolith and say, look, we can just expose a new API that does all of the things we need to do to integrate with one of those voice applications. Or you create a brand new library, use the programming language that's the best fit to write code for Alexa or Google Assistant, and then call back into your existing monolith. And guess what? Now you have a second app, and people will understand why you have the second app. It
Mm.
made a lot of sense. And
Yeah.
that's the pragmatic way of going about it.
And I think it's compelling that you would take a cross-cutting service like security, authentication, authorization, and move that out because every element of your application is going to benefit from that. Whether it's at login time, checking that you're authorized to use a certain feature, all of those places that your application would have bogged down, that would have been touched, like you were saying, it now just becomes a ton easier because it's being handed off to somewhere else.
I'm going to grab a question if you don't mind. I see one that I want to answer.
Please.
What is Kelsey's point of view with microservices? It's in that third column at the top. What is his
This,
point of view on microservices helpers like Spring Cloud and Stilto? I
yeah, there
love
we
this
go.
question because this is where I think things are actually going to go.
Okay.
I love what platforms are doing, like Kubernetes. They do a lot of stuff for you, but honestly, I think they can only meet you halfway.
Mm,
Let's think about application tracing, for example. Your load balancer gets a call from your client,
yeah.
and there's a header there that says, I'm making a request from an iPhone. And it hits the load balancer, and the load balancer is really smart, and it takes that trace header and it puts it into the thing that it passes to you, or maybe lets it pass through. And then along the way, it comes to you. Now, your job, and you really can't delegate this too much, but your job is to take that header, and if you're going to connect to a database and you want to have deep level tracing, you may take the header out of your HTTP request and put it into the tracing library that talks to your database So that way your database can also add to the tracing so you can see this end-to-end thing.
Yeah.
And doing that from scratch, and I've tried it in many languages, it sucks.
It's difficult.
It's difficult, hard to get consistency. So let's get back to the question. When you start to think about Spring Cloud, just like Kubernetes makes it easy to leverage a bunch of infrastructure patterns, well, the other half of the responsibility lies with the developer, structured logging, metrics, tracing, etc., etc. Now, instead of you writing that from scratch, there are frameworks like Spring Cloud that say, you know what? I know how to create structured logs. I know how to send traces. I even know how to extract the traces from load balancers and proxies and aggregate them to client calls that you do below. And I think that's really a thing that lets you speed up. So this is where we start to get into libraries versus frameworks, right? So before
Yeah.
Spring, I remember it was all about JBoss,
Mm.
WebLogic. Those things were fairly big, and they came with the high memory cost or maybe some additional complexity that you didn't need. And now seeing the same community, the Spring community, come up with Spring Cloud and Spring Boot, that just says, hey, let's just take a library approach, import a line, and then you can just do all the things you need without a lot of boilerplate. So I love those things.
Yeah, and there's a number of vendors out there that are building tools to help with that type of tracing going on through your operations, and being able to attach and orchestrate all of the various interactions is kind of important to, like you're saying, get the entire flow, be able to visualize everything that's happening there.
Yep.
I think there's one more question we can bring up here. Hugo has a question here. What are your thoughts on using Dapper to run your microservice applications as an alternative to using Kubernetes?
This is a good question. I actually kicked the tires on Dapper the other day, and I'm not an expert, so if I'm getting a few things wrong, just make fun of me on Twitter or something. It's okay. I would say this. I haven't seen a situation where you can just use Dapper by itself with no VMs, no orchestrator to run the sidecars that Dapper does. So for those that don't understand Dapper like I do, the idea with Dapper is a lot it feels similar to what you see with like serverless projects where I can put a lot of logic in these sidecar adapters, like how to read a message off a message queue, how to grab a HTTP request. Maybe I can do all of that outside of my app and make my app super simple. So what you end up with is it feels like a blend between Spring Boot and JBoss, where you have a lot of logic that sits on the outside of you. And this is a really nice pattern, right? This adapter pattern or the sidecar, where we put a lot of logic there. And ideally, the trade-off is my app becomes much easier to write. But here's the thing, though. When you think about that, whether I pick Spring Boot, JBoss, or Dapper to do this kind of application server effect, I
Yeah.
still need an orchestrator to map those things to resources so my app can actually run. So it's
Okay.
more of my mind would be Dapper and Kubernetes. And I guess the last thing here as we wrap up is here's where the sidecars fall apart. In some of the serverless platforms, you can't run a sidecar at all. So then you're not able to make that kind of trade-off. And this is where I think libraries become interesting again. So I can
Okay.
imagine in a world in Dapper where you have a proxy list, and I think you can probably do it, import Dapper as a library. Now you're in that Spring Boot territory, and now you have more flexibility in using even serverless platforms and getting all of those benefits.
Very cool. All right. You know what? There's a follow-up question here to that authentication uh, discussion that we had just a second ago. Let me put this up here. Is it not a little bit of overhead to authenticate each request between microservices? Will it impact performance? How do you handle this?
Yeah, it's funny. I don't have time to show you the end-to-end demo, but this is something that I do have a lot of code around. So this is where I think JOT tokens, JWT, come into play, right? So there's various ways of caching, and authentication has been a problem everywhere, even in the cloud or LDAP or even Active Directory. This is why we have
Mm,
caches. So in the stateless world, JOT tokens, I think, play a major role in security. So I'm going to walk you through the flow really quickly. And this is still true today for most things, even though people say passwords are bad, they're still largely used in many cases. So let's walk through one flow, not the only flow. You have a separate service that's the off service. You are correct. If I had to have this service over here call the authentication service every time or the client authenticate every time, it will be
yeah.
a nightmare. So
Mm.
what do we do instead? Well, we have the client log in once, and then we figure out who they are. And depending on what your security requirements are, we may give them back a token, like Active Directory does under the covers. You get a ticket or something.
Yep.
And once you have this thing in hand, you would say, look, I authenticate that this person is who they say they are with maybe a few attributes, and I give them back a token.
Okay.
Now, the other services in the stack, they should have a way of verifying that that token is legit and still valid. So what that does is now as a client, I may be required to attach that token in every request that I do. So guess what? On the client side, I'm not logging in a bunch of times. Maybe I'm caching that token. And as
Sure.
long as it's not expired, I'm going to make my request to the other services. And now the
Mm.
services can avoid the network altogether because they have maybe a private key where they
Okay.
can actually verify the signature of the token. And if it's something that I trust, then it's a bit safe for me to go and read what's in there and say, oh, you are Kelsey with this email address because everything in that signed token came from an authentication service I trust. And then I can do things on your behalf and avoid the extra network hop.
Very cool. All right. That's all the time we have, Kelsey. Thank you so much for joining us here for
Awesome.
.NET Conf. Really
Thanks for having me.
appreciate you joining us. And we're gonna take a quick break while we get ready for our next speaker. All righty. Take care, Kelsey.